Do you know the concept of trigonometric curves from inverse trigonometric function, which is a very important topic for class 12 and competitive exams like JEE? I'll teach you with easiest methods that your teacher never told. Stay till the end and you'll never forget this concept. Come on. To understand the curves, first we need to know the domain and range of each inverse functions. There are 6 functions in inverse trigonometric functions. They are sine inverse of x, cos inverse of x, tan inverse of x, cot inverse of x, secant inverse of x and cosecant inverse of x. For sine inverse of x, domain is between -1 to 1 and range is between -pi/2 to pi/2. For cos inverse of x, domain is between -1 to 1 and range is between 0 to pi. Similarly, for tan inverse of x, domain is between -infinity to infinity and range is between -pi/2 to pi/2. For cot inverse of x, domain is between -infinity to infinity as similar like tan inverse of x and range is between 0 to pi. For cosecant inverse of x, domain is between -infinity to -1 union of 1 to infinity and range is between -pi/2 to pi/2 where x is not equal to 0. Secant inverse of x, where the domain is between -infinity to -1, again union of 1 comma infinity and range is between -pi/2 to pi/2 where x is not equal to 0. Right, here cosecant inverse of x and secant inverse of x are same. Let's plot the graph. Graph of sine inverse of x, right? See the figure, it's the curve of sine inverse. The domain is x belongs to -1 to 1, range is y belongs to -pi/2 to pi/2 and when x equal to -1, the value of y is -pi/2, x is 0, y is also 0 and x is 1, y is pi/2. Now for graph of cos inverse of x, see the figure, it is the curve for cos inverse. The domain is x belongs to -1 to 1, range is y belongs to 0 to pi. When x equal to -1, y equal to pi, x equal to 0, y equal to pi/2 and x equal to 1, y equal to 0, right? Now graph of tan inverse of x, see the figure, it is the curve for tan inverse. The domain is x belongs to -infinity to infinity, range is y belongs to -pi/2 to pi/2. When x equal to 0, y equal to 0, as x tends to infinity, that is x is infinity and y is pi/2, and when x is -infinity, y is -pi/2. So this graph is actually smooth S shaped curve, right? See the graph, a smooth S shaped curve. Now for graph of cosecant inverse of x, see the figure, it is for the curve of cosecant inverse. The domain is -infinity to closed bracket for -1, universal of opening the bracket 1 comma infinity, where the range is -pi/2 to pi/2 with a condition y not equal to 0 and when x equal to 1, y equal to pi/2, x equal to -1 and y equal to -pi/2. This curve is again similar to sine inverse of x but doesn't exist between -1 and 1 because cosecant is undefined for -1 and 1, right? Next, the graph of secant inverse of x, again see the figure, the curve shows the secant inverse of x graph. The domain is between -infinity comma -1, universal of 1 comma infinity. The range is between 0 comma pi, right, where y is not equal to pi/2, right? And when x equal to 1, y equal to 0, then x equal to -1, y equal to pi. Again the curve is similar to cos inverse of x but avoids y equal to pi/2, that is a range where y is not equal to pi/2. So see the graph, it has two separate branches, one is in the first quadrant and another is in the second quadrant. So this is the graph of secant inverse of x. At last, graph of cot inverse of x. See the figure, it is a curve of cot inverse. The domain is between minus infinity to infinity and range is 0 to pi, and when x equal to 0, y equal to pi by 2. Where x tends to infinity, then y tends to 0. X tends to minus infinity, y tends to pi. So this is again a downward curve that starts from pi and move towards 0 as x increases, right? It's for cot inverse of x. Now we came to conclusion, right? The cosecant inverse of x and secant inverse of x have two separate branches. Cot inverse of x is similar to tan inverse of x, but it is flipped, right? And it's a easy hack to remember these graphs, right? A bonus tip, a quick hack to easily remember the graph shapes of inverse trigonometric functions. For sine inverse of x and tan inverse of x, both the graphs increase from left to right, but sine inverse of x is bounded from minus pi by 2 to pi by 2, while tan inverse of x stretches from minus pi by 2 to pi by 2, but asymptotic at the end. By looking the graph, you can clearly understand what is the major difference between sine inverse of x and tan inverse of x. Similarly, for cos inverse of x, it moves from top to bottom between 0 to pi. Then for cot inverse of x, it moves from again top to bottom between 0 to pi, but never touches x-axis, right? For cot inverse of x is as similar like cos inverse of x, but it never touches the x-axis. Then for secant inverse of x and cosecant inverse of x, both discontinuous graph with gap in the middle, right? Just look at the graph how it is. The both have discontinuous graph with gaps in the middle. So this is the bonus tip for the graph of each inverse trigonometric functions, right? Next videos we'll see more tricky concepts from various chapters, right? So hit the subscriber button and like the video if you really enjoyed it, and do share to your friends. Thank you.